Hello students, welcome to the class. So here I have the next set of questions on the topic some basic concepts of structure of atom. Yeah, we have discussed around 20 questions and here I have the 21st question. In a Bohr's model of an atom, when an electron jumps from n equal to 1 to n equal to 3, how much energy will be emitted or absorbed? So we have seen Bohr's model. Yes, what in Bohr's model we have seen? This is the ground state, n equal to 1. Then we have n equal to 2, n equal to 3, n equal to 4, n equal to 5. These are the energy levels. Yes. So here I can write it like this. So these are the energy levels. Five and so on. So they have said when an electron jumps from n equal to 1, so electron is present in this state, and when it jumps from n equal to 1 to n equal to 3, from the first energy level to the third energy level, when the electron jumps, that means it is jumping from lower energy level to higher energy level, how much energy is emitted or absorbed? Energy will be absorbed, right? Only when the electron absorbs some energy, it will jump from lower energy state to higher energy state, and that is called excitation. And that state is called excited state. This is the ground state for the electron. Absorbs energy, correct? Okay. So how much energy? How do we calculate the energy now? Okay. So let us see how to calculate the energy. So we know that energy of an atom when n is equal to 1. When n is equal to 1, E1 is equal to what? E1 is equal to minus 1312. I have told you this formula. 1 square. Z square. Z is 1. So for that 1 square. That is equal to how much? Minus 1312 kilojoules per mole. Correct? Kilojoules per mole. Similarly, energy of an atom when it is in third energy level. So E3 is equal to minus 1312. Z is hydrogen atom, so 1 square divided by 3 square, because third energy level n square is 3. 3 square is 9. This comes out to 3 3s are 9 minus 1312, 1312 divided by 9. It comes out to around minus 145.7 kilojoules per mole. Correct? So energy is absorbed when electron jumps from. So energy is what? I have told you just now. Energy is absorbed. It is not emitted. Because absorbed. Because electron jumps from n equal to 1 to n equal to 3. Yes. Now how much energy is absorbed? So we will have to find the change in energy, right? So E3 minus E1. When you subtract the energy from E3 to E3 and E1, you will get change in energy. So how much is E3? Minus 145.7 minus of minus 1312 kilojoules. So 1312 minus 145.7 comes out around 66.3 kilojoules per mole. Correct? But this is energy in terms of kilojoules per mole. They have asked us in ergs. So what this is for an atom. They have asked how much energy when an electron jumps. So this is an atom. So when we consider about particles, it comes out to 0.3 divided by Avogadro number 6.02 into 10 raised to 23, and that is equal to 193.6 into 10 raised to minus 23. Yes or no? Understanding? This is for an electron. This is for atom. Understanding? Now, we know that what is 1 joule is equal to how many ergs? 1 joule is equal to 10 raised to 7 ergs. So here we have 193.6 into 10 raised to minus 23 joules. Convert it to ergs. 193.6 into 10 raised to minus 23 plus 7. It comes out to 193.6 into 10 raised to minus 10. 10 raised to minus 10. No, so 23 minus 7 is how much? 13. How much you get? 16 to minus 16. 193.6 into 10 raised to minus 16. Minus 23 plus 7. So it is 10 raised to minus 3. 13. Correct? Let us see. Okay. So we get here 193.6 into 10 raised to minus 23. Okay. This is kilojoules. Converted to joules, remove kilo. So what do we get? 193.6 into 10 raised to minus 20 joules. Kilo has to be removed. Into 10 raised to 3 we do. 10 raised to 3. So now this has to be converted to ergs. So I can write 193.6 into 10 raised to minus 20 plus 7. This comes out to how much? 193.6 into 10 raised to minus 13. Or I can write it as 1, 2, 3, shifting the decimal points 3 digits to the left, 0.193 into 10 raised to minus 10 ergs. 10 raised to minus 10 ergs. Understanding? So I want what is the options given. In that way, I need the option. So here the correct option is 0.1936 into 10 raised to minus 10 ergs. Yes. Okay. Next question. The radius of hydrogen atom in the ground state is 0.53 angstrom. The radius of lithium ion in the similar state. So they have given the radius of hydrogen atom in the ground state. Yes. So when we say ground state, how much of hydrogen? Ground state of hydrogen they have said. So what will be n equal to? N will be equal to 1. And the radius of hydrogen atom in the ground state. So R1 is equal to, we already know this is called Bohr's radius, 0.53 angstrom, 529, which is taken as 53. What is the atomic number of lithium? Lithium atomic number is 3. Now they have asked radius of lithium plus 2 ion. Correct? So R in the same state they have asked, in the similar state. Yes, R1 of lithium plus 2 ion is equal to 0.53 angstrom. So formula will be what? So formula is R into n square by z. So R naught, this is Bohr's radius, 0.53 into n is what? State 1 square divided by z is what? 3. So 0.53 divided by 3 comes out to what? 3 ones are 0.3 ones are 2 remains, 3 sevens are 21. So it comes out to 0.17 angstrom. 0.17 angstrom. Let us see. Yes, it is option C. It is option C. Next question. The energy of an electron in the nth Bohr's orbit of hydrogen atom is. We already have solved this. Energy of the electron in nth orbit of hydrogen atom is given by minus 13.6 divided by n square electron volt. So which is the correct option? 13.6 divided by n square electron volt. So this is the correct option. Yes, this is the correct option. Next question. The spectrum of helium is expected to be similar to that of He. Helium, they have said, it is expected to be similar to that of helium. Atomic number is 2. Helium has how many electrons? It has 2 electrons. Yes. Which of the following atom or ion contains 2 electrons? It will be similar. The spectrum will be similar to that. Hydrogen, 1 electron. Lithium is 3 electrons. Lithium plus. So lithium is 3 electrons. Lithium plus means what? 3 minus 1, 2. So lithium has got 2 electrons. Sodium, 11 electrons. Helium plus, helium has 2 electrons, plus means -1, there is 1 electron. So helium, it will have the spectrum similar to that of lithium plus ion, Li plus ion. Yes, okay. Moving to the next question. If the radius of the first orbit, if r is the radius of first orbit, the radius of nth orbit of hydrogen atom is given by. This also we have solved. The radius of nth orbit Bohr had given of hydrogen atom is given by, we write it as radius of nth orbit is equal to r naught n square. R naught n square, where R naught is called Bohr's radius. And its value is 0.53 angstrom or 529 angstrom, you can say. Yes. So R naught is the Bohr's radius, or you can call it as radius of first orbit. Radius of first orbit. Yes, you can denote it as R or you can denote it as R naught. Therefore, which is the correct formula? Rn square. Rn square. If it is given R naught, you'll write R naught n square. If it is given R, you'll write Rn square. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is hydrogen atom de Broglie wavelength they have asked. So what is the question? The de Broglie wavelength of an electron in second Bohr orbit. Yes, second orbit means it is second shell. So n is equal to 2. N is equal to 2. When we have second shell, we should be also knowing Bohr's radius. What is Bohr's radius? R naught is equal to 0.529 angstrom, or I can also write it as 52.9. Angstrom means what? 0.529 into 10 raised to minus 10. Or I can shift the decimal points 2 digits here, 10 raised to minus 2 again. So it can be written as into 10 raised to minus 12 meters, which is nothing but 52.9 picometers. 1 picometer is equal to 10 raised to minus 12 meters. So I can write it like this because my options are there in picometer. So I convert it to picometer. Okay. So what is the radius of nth orbit? Formula for radius of nth orbit. Rn is equal to A naught n square. A naught is Bohr's radius, or R naught you can write it as. Okay. So what is the value? 52.9 into n is how much? 2 square. 2 square is how much? 4. 52.9 into 4 comes out to 211.6. Unit is picometers. Okay. But here, de Broglie wavelength they have said. Yes. The angular, we know that according to Bohr's orbit, only those electrons are allowed whose angular momentum is integral multiple of h upon 2 pi, correct? H upon 2 pi. So I can write here, what is n? It is 2. 2 into h upon 2 pi. Yes. Or this can be written as h upon pi. Yes. So what is h? Therefore, I can write mvr pi is equal to h. It is h. Okay. De Broglie wavelength. You will get to know why I took this h. De Broglie wavelength lambda is equal to what? H upon mv. Correct? And I know the value of h. What is the value of h? mvr pi upon mv. mv gets cancelled. What is the value of r? 211.6 pi picometers. Correct? Understood? 2116 pi picometers. Understood? How did we get this? This is required. Yes, de Broglie wavelength, second Bohr orbit. So this is required. Once you know the value of h, you can find. This is some different question. So what we did, we first calculated the radius of Bohr's orbit, nth orbit. Then angular, we know one of the postulate of Bohr's model says that angular momentum of an electron is integral multiple of h upon 2 pi. So hn is what? 2. So 2 into h upon 2 pi, h by pi. I want the value of h to solve de Broglie wavelength. You cannot say I will take a 6.626 into 10 raised to minus 34 joules, because that is not required in my options. So what I did, I found MVR pi is equal to h, lambda is equal to m by v. MV gets cancelled. I know the value of r here, 211.6 pi picometers. So the option 211.6 pi picometers is the correct option. Correct? Yes. Next question. A 0.66 kg ball is moving with a speed of 100 meters per second. The associated wavelength will be, yes, they have given the mass of the ball and the velocity is given. What is asked? Wavelength. According to de Broglie equation again, mass and velocity is given. So will you de Broglie's wavelength equation, you can say. Lambda is equal to h upon mv. Correct? Mass is given, velocity is given. So let us see what all is given. H is what? H is 6.626 into 10 raised to minus 34 joules second. How much is mass? 0.66 kg. Yes, 0.66 kg. Then what is velocity? It is 100 meters per second. All are there in the SI unit, so I need not convert. So 6.626 into 10 raised to minus 34 divided by 0.66 into 100. So this comes out to 66. So 6.66 by 66. 1 into 0.1 here. So 0.1 is 10 raised to minus 1. I'll get it like this, 10 raised to minus 34. Or I can write it as 1 into 10 raised to minus 35. What is the unit? Meters is the unit, because 0.1 is what? 10 raised to minus 1. So 1 into 10 raised to minus 35. Yes. So the correct option is there. Correct option is 1 into 10 raised to minus 35 meters. It is option C. Next, if the uncertainty in position and momentum are equal, then uncertainty in velocity is, see, this is the question on Heisenberg uncertainty principle. From Heisenberg uncertainty principle, we know that delta x into delta p is greater than or equal to h upon 4 pi, correct? Or I can even write it as delta x into m delta v, because velocity they have said h by 4 pi. Okay. Or I can write it as m delta v is equal to h by 4 pi. See, what is delta x? They have said in the question, what they have said, uncertainty position is equal to uncertainty in momentum. So when delta x and delta p are same, this can be written, instead of taking it like this before, I can write this as delta p only, the whole square, because I can substitute delta x as delta p. So delta p whole square becomes what? M delta v the whole square, correct? M delta v the whole square. Yes or no? Because question says uncertainty in position and momentum are equal. So delta p the whole square I can write is greater than or equal to h by 4 pi. So this becomes delta v square is equal to h by 4 pi into 1 by m square. One by m square, correct? Okay. So delta v will be equal to what? It will be equal to root of 1 by m square into h by 4 pi. M square comes out as m, 4 comes out as 2. Therefore, I can write, sorry, this is delta v. Okay, so here square, Remove the square and put the square root. So here delta V will be equal to m and 2 comes out. So 1 by 2m, the root of h by pi. Yes, this is delta V, uncertainty in velocity. So delta V, velocity, uncertainty in velocity is equal to 1 by 2m, the root of h by pi. I hope you understood. What we did? Simply, we took delta x into delta p greater than equal to h upon 4 pi. This is Heisenberg's uncertainty principle. Yes, since according to the question, uncertainty in position and momentum are equal. So delta x is equal to delta p. Therefore, I can write it as delta p into delta p, or I can write it as delta p the whole square. Correct? Delta p the whole square, and that is equal to h by 4 pi. Equal also I can keep. What is delta p? M delta v the whole square is equal to h by 4 pi. So this becomes delta v square is equal to 1 by m square into h by 4 pi. Okay, so what will be delta v? It will be root of 1 by m square into h. So h by m square into 4 pi. So take m square comes out, 4 comes out. So delta v will be equal to uncertainty in position 1 by 2m, the root of h by pi. This is the correct option. This is the correct option. So option C is the correct option. I hope it is clear. Next, the measurement of the electron position associated with an uncertainty in momentum, which is equal to 1 into 10 raised to minus 18 grams per centimeter per second. So this is uncertainty in momentum. The uncertainty in electron velocity is uncertainty in, again, a question on Heisenberg uncertainty principle. So what does it says? They have said uncertainty in momentum. Okay, delta P can be also written as m delta V because mass is given, correct? Okay, and they have said how much it is equal to? It is equal to 1 into 10 raised to minus 18 grams centimeter per second. This is given. And they have asked us to calculate uncertainty in velocity. So how do we calculate it? So if m delta V is equal to 1 into 10 raised to minus 18, delta V will be equal to 1 into 10 raised to minus 18 divided by mass. How much mass is given? 1 into 10 raised to minus 18 divided by mass given is 9 into 10 raised to minus 28 grams. If the mass was given in kg, you would have converted this also in kg, but it is given in mass. So 1 by 9 is how much? 1.1 into 10 raised to. One divided by 9 comes out to 0.11 into 10 raised to minus 10, correct? Minus 10. That can be written as 1.1 into 10 raised to so you are shifting to the right. So plus 1 it becomes. So when it becomes plus 1, it becomes minus 9 centimeter per second. So this is the answer. So 1.1 into 10 raised to minus 9 centimeter per second. Sorry, plus 9 centimeter per second. Because here what happens? Here what happens? This plus, it goes up. So 10 raised to minus 18 plus 28. So this becomes plus 10. When it becomes plus 10, you're shifting decimal point here. So minus 1. So this becomes plus 9. So 1.1 into 10 raised to 9 centimeter per second. Next question. Given the mass of the electron is 9.11 into 10 raised to minus 31 kg. Planck constant is 6.626 into 10 raised to minus 34 joules. The uncertainty involved in the measurement of velocity within a distance of 0.1 angstrom. Okay, 0.1 angstrom. According to Heisenberg uncertainty principle. Yes, according to Heisenberg uncertainty principle, we know that delta x into m delta v is greater than or equal to h by 4 pi, correct? Okay. What is the velocity delta x, that is uncertainty in position given? Distance is given, right? 0.1 angstrom. Rest all are there in SI units. So I'll convert the 0.1 angstrom in SI unit. So I can write the answer distance as 0.1 into 10 raised to minus 10, because 1 angstrom is equal to 10 raised to minus 10 meters. Okay. Into, what is the mass given? Mass of the electron is 9.11 into 10 raised to minus 34. Into, what is the velocity given? Velocity is what we are supposed to find. That is equal to Planck's constant 6.626 into 10 raised to minus 34 divided by 4 into pi values 3.142. Yes, substitute it. Yes, so therefore I can write it as delta V is equal to 6.626 into 10 raised to minus 34 the whole divided by 0.1 into 10 raised to minus 10 into 9.11 into 10 raised to minus 34 into 4 into 3.142. Correct? Yes. And solve it out. When you solve everything, you will get the answer 5.79 into 10 raised to minus 10 minus 34 minus 44. When it goes to the numerator, plus 44 minus 34 becomes 10. But here we'll get it in decimal points. So when I shift the decimal points, I'll get the answer, that is 6 meters per second. Meters per second. So the correct option is 5.79 into 10 raised to 6 meters per second. Option B is the correct option. Next question. The uncertainty in momentum of an electron is 1 into 10 raised to minus 5 kg meter per second. Uncertainty in position. Direct question. So uncertainty in momentum, delta P is how much? 1 into 10 raised to minus 5 kg meter per second in SI units. They have asked uncertainty in position, delta x. So delta x is equal to h upon 4 pi delta p, correct? So 6.626, it is given only 6.62 into 10 raised to minus 34 divided by 4 into 3.14 into p. Delta p is how much? 10 raised to minus 5. Yes, solve it out. You will get the answer 5.27 into 10 raised to minus 30 meters. The answer will be 5.27 into 10 raised to minus 30 meters. 5.27 into 10 raised to minus 30 meters. So correct option is option A. Yes, so this is question on uncertainty, Heisenberg's uncertainty principle. The de Broglie wavelength of a particle with mass 1 gram and velocity 100 meters per second. See, gram is given and meters per second is given. Okay, so let us see. De Broglie wavelength, we know lambda is equal to h by mv, and they have given 100 meters per second and 1 gram, and they have asked the de Broglie wavelength in meters. So I can write it as 6.626 into 10 raised to minus 34 divided by mass. 1 gram is equal to 1 kg is equal to 1000 grams. Therefore, 1 gram is equal to 10 raised to minus 3 kg. 10 raised to minus 3 kg into how much? 100 meters per second. 100 meters per second. Solve it out. So 10 raised to minus 3 and this is 10 raised to 2. So this becomes 10 raised to minus 1. Goes to the numerator. 10 raised to minus 35 it becomes. This is minus 3 and 2 plus 2. So 10 raised to minus 3 plus 2. It becomes minus 1 When it goes to the numerator, it becomes plus 1. So it is 6.626 into 10 raised to minus 33 meters. Let us see the answers. 6.10 raised to minus 33. So this is the nearer answer. So option C is the correct option. Rest all 35, 34, 35 is there. So option C is the correct option, right? Okay. Next question. The position of both an electron and a helium atom is known within 1 nanometer. See, electron and helium atom is known within 1 nanometer. Further, the momentum of the electron is known within 5 into 10 raised to minus 26 kg meter per second. The minimum uncertainty in the measurement of momentum of helium atom. See, electron and helium atom they have considered. Okay. Now, according to our very interesting question, according to Heisenberg's uncertainty principle, according to this principle, what it says, the product of uncertainty in position and uncertainty in momentum is constant for a particle. Yes or no? Because it is equal to h by 4 pi. That is what? Delta x into delta p is h by 4 pi. It is constant. Correct? They have said delta x is 1 nanometer for both. For both. For what? For both what? Electron and helium atom. So can I say delta P is also same for both? Yes or no? According to our uncertainty principle, if delta X is 1 nanometer for both electrons, then delta P will also be same for both electron and helium atom. For electron and helium atom. Thus, uncertainty in momentum of helium atom is how much? If uncertainty in momentum of electron they have given, uncertainty in momentum of electron they have given 5 into 10 raised to minus 26. Then uncertainty in momentum of helium atom will be how much? 5 into 10 raised to minus 26 kg meter per second. It will be also same. It will be also same. So it is 5 into 10 raised to minus 26 kg meter per second. Okay. Next question. Uncertainty in position of a part of an electron. Mass is given in grams. 9.1 into 10 raised to minus 28 grams. Moving with a velocity of 3 into 10 raised to 4 centimeter per second. Accurate up to 0.001% will be. So they have given everything. Everything is not in SI units. So I need not worry about the conversion factors. So they have said mass of the electron is how much? Mass of electron, I can write it as mass of electron is equal to 9.1 into 10 raised to minus 28 grams. This is given. Okay. Then what they have said? Velocity of the electron. Velocity of electron is also given. Velocity of electron is 3 into 10 raised to 4 centimeter per second. Okay. Accuracy is given. It is accurate up to. So accuracy is 0.001%. What does that mean? 0. It means 0.001 divided by 100. Yes. And what is Planck's constant given? Is it given? No. So we know that use Planck's constant by 4 pi in uncertainty expression. Okay, so Planck's constant is also given 6.626 into 10 raised to minus 27 ergs second. Correct? So, what is the actual velocity of the electron? Yes, delta V will be equal to what? So, it will be equal to velocity of the electron into accuracy, right? What is the velocity? 3 into 10 raised to 4. And how much accuracy is given? 0.001 divided by 100. Correct? This comes out to, this is 10 raised to 1, 2, 3. Minus 3, 10 raised to minus 2, 5. So minus 5, this becomes 0.3 centimeter per second. That's it. Actual velocity. Accuracy is given. No, so multiply that accuracy with the velocity. You will get actual velocity. So they have asked uncertainty in position. Is it this what you have asked? So what they have said? Uncertainty in position. So delta x will be equal to what? H upon 4 pi m delta v. So H is what? 6.626 into 10 raised to minus 27 ergs. 4 into 3 point, they have asked us, so 4 into 3.14 into 9.1 into 10 raised to minus 28 into velocity is 0.3. That's it. Solve it out. You will get the answer 1.93 centimeters. Understood? When accuracy is given with the velocity of the electron is this and it is so much accurate means what? We'll multiply it with this. Understanding? Yes? So what is the answer? 1.93 centimeters is the answer. Next, which of the following statements do not form a part of Bohr's model of an atom? Do not form Bohr's model of an atom. Okay. First option, energy of electrons in the orbits are quantized. Yes or no? First point, it is correct because the energy of every orbit, it is fixed. So when electron is revolving in its particular orbit, it will neither lose energy nor gain energy. So energy remains fixed. Therefore, those orbits, he called them as energy levels or he called them as stationary states. Right? Stationary states. The electron in the orbit nearest to the nucleus has lowest energy. Yes, that is also correct. When you write the orbits in the when you write these orbits, so let me say this is nucleus. This is n is equal to 1, n is equal to 2, n is equal to 3. First orbit is associated with energy say E1, E2, E3. As you move away from the nucleus, the energy goes on increasing. It becomes more negative. So third is having more energy than second than first. So lowest the electron in the orbit nearest to the nucleus, we have lowest energy. Yes, it has lowest energy. So that is also correct. Electrons revolve in different orbits around the nucleus. Yes, that was the corrected statement of Bohr from Rutherford's model. Rutherford did not say that whether the electrons are having different orbits or same orbits. He just said they are revolving in orbits. But Bohr said that they revolve in different orbits around the nucleus. The position of velocity of electrons in the orbit cannot be determined simultaneously. No, he said you can determine the exact position and velocity. This was Heisenberg's uncertainty principle, right? This is Heisenberg's uncertainty principle. It is not the postulate of Bohr. So what is the correct option? The correct option is this. This is not the postulate of Bohr. Correct? Next question. 4d, 5p, 5f and 6p orbitals are arranged in the order of decreasing energy. Which one is correct? So when you are working with and decrease energy changes of the orbitals, which orbitals are given? 4d, 5p, 5f and 6p. Arrange them in the decreasing order. We will go for n plus L rule. So where n plus L rule is more, that will have more energy. Where n plus L rule is less, that will have less energy. So let us see. 4 into d, and we know that n represents the shell and L represents, if it is 0 it is S, if it is 1 it is P, if it is 2 it is D, if it is 3 it is F. So 4 plus D means what? It is 2, 6. So n plus L value is 6. 5 plus 1, 6. 5 plus 3, 8. 6 plus 2, 8. Now, these two are having same n plus L value, these two are having same n plus value. So, naturally, which should come first? When same n plus L value is there, the one with lower n value will have lower energy. So, lower energy is 4D, then comes 5P, then comes 5F, and then comes 6P. So, which is having more energy? 6P. 5F. So 5F is this. I'm sorry. Here P is 1, right? So 6 plus 1 is 7. So 4D, 5P, 6P, and then 5F. So which is having a higher energy? 5F has more energy. Then comes 6P. Then out of these two, which is having more energy? 5P, and then comes 4D. Correct? So which is the correct option? Let us see which is the correct option which follows this order. Yes. So it is option B. Higher the value of n plus L for an orbital, higher is the energy. However, if the two different orbitals have same n plus L value, the orbital with lower value of n has lower energy. So decreasing order is 5F, 6P, 5P, and 4D. Correct? Next, orbital having 3 angular nodes and 3 total nodes. We have studied that there are two types of nodes. Nodes are what? The region where probability of finding the electron is 0. So probability density is 0. Radial nodes and angular nodes. How do we calculate radial nodes? N minus L minus 1. Angular nodes are L. Total nodes is N minus 1. N minus 1. Correct? Okay. So radial nodes are also called spherical nodes. Okay. So the question is now orbital having 3 angular nodes and 3 total nodes. Okay. Okay. So number of spherical nodes in any orbital will be n minus L minus 1. Number of angular nodes is 3 they are saying. So if angular nodes symbolically we represent it as L and L is 3, then radial nodes will be how many? Total number of nodes will be how many? N minus 1. That is equal to 3 they are saying. Correct? They are saying that is also equal to 3. So how many? N will be equal to what? N will be equal to 4. Understanding? They are saying total nodes are 3. They are saying total nodes are 3. And we know the formula. Angular nodes L. And they have said angular nodes are 3. And total nodes are also 3. And formula is N minus 1. So how many? What is will be N equal to? N will be equal to 4. N is 4 means what? It is 4th shell. And L is 3 means what? If L is 3, it is for D. So which is the L is 3, it is for F. So what is the orbital? The orbital is 4F. Don't get confused. L is 0, S orbital. L is 1, P subshell. L is 2, D. L is 3, F. Understood? So this is L is equal to 3. We directly understand that it is F. And N minus 1, total nodes are 3 they are saying. So N minus 1 is 3. That means N will be equal to 4. So 4th shell and L is 3. So it is 4F orbital. It is 4F orbital. Option C is the correct option. Which one is the wrong statement? Total orbital angular momentum of an electron in S orbital is equal to 0. Yes. Angular momentum. Okay. That is azimuthal quantum number for S orbital. L is equal to 0 for S orbital, S subshell. Correct? Angular momentum is what? It is azimuthal quantum number. So m values vary from minus L to plus L, including 0. But L is 0, so m also will be 0. So total orbital angular momentum of an electron in s orbital is 0. That is correct statement. Second, an orbital is designated by 3 quantum numbers, while an electron in an atom is designated by 4 quantum numbers. Yes, orbital has 3 quantum numbers, n, l and m. But electron has 4 quantum numbers, n, l, m and s. Spin quantum number also comes. The electronic configuration of nitrogen is this. They have given electronic configuration of nitrogen 1s2, 2s2, 2p3. Orbitally, they have shown spin up, spin down, spin up, spin down, spin up, spin up. No, it should be spin up, spin up, spin up. According to which rule? According to Hund's rule of maximum multiplicity. Multiplicity. Yes, the correct configuration of nitrogen, it comes like this, not like this. So this is the wrong statement. The value of m for dz square is 0. This is also correct. So which is the wrong statement? It is option C. We don't represent it like that. Next, which one is the wrong statement? Wrong statement again. The uncertainty principle is delta E into delta T is greater than or equal to h upon 4 pi. Yes, we can represent it like this also. Half-filled and fully filled orbitals have greater stability due to greater exchange energy, greater symmetry, and more balanced arrangement. Yes, the reasons for half-filled and completely filled orbitals, why they are half-filled, why they are extra stability of half-filled and completely filled orbitals, it is due to symmetrical arrangement. Greater the symmetry, greater is the energy. And next is due to exchange energy. As the number of exchanges are more, exchange energy increases. Greater the exchange energy, greater is the stability, and more balanced arrangement is nothing but symmetry. The energy of 2s orbital is less than the energy of 2p orbital. So the energy of 2s orbital is less than 2p immediately, right? N plus L rule. 2 plus 0 is 2. 2 plus 1 is 3. So energy of 2s orbital is less than the energy of 2p orbital. In case of hydrogen-like atoms, here the question comes. This is true by N plus L rule. But in case of hydrogen-like atoms, energy depends on what? Energy depends on, please make a point of it, energy depends on principal quantum number. It depends on principal quantum number, and here 2s and 2p have same principal quantum number, they have same n, therefore they will have same energy, equal energy. Understanding? So I cannot say that based on n plus L rule, 2s is having lower energy than 2p in case of hydrogen-like atoms. No, in case of hydrogen and hydrogen-like atoms, energy depends on the principal quantum number. If principal quantum number is same, then energy is also same. De Broglie wavelength is given by lambda is equal to h upon mv, where m is mass, v is velocity of the particle. Yes, that is correct. So this is the wrong statement. Please remember this. For hydrogen and hydrogen-like atoms, energy depends on principal quantum number. So 2s and 2p have same principal quantum number. Therefore, they will have equal energy. They will have equal energy. Okay. Then, how many electrons can fit in the orbital for which n is equal to 3 and L is equal to 1? So they say how many electrons can fit. N is equal to 3, L is equal to 1. N is equal to 3 means what? It is third shell. L is equal to means it is p subshell, correct? So it is 3p subshell. And a particular 3p orbital, if they have said orbital, we know that 3p subshell has got 3 orientations according to azimuthal quantum number. They have not asked subshell, they have asked orbital. So there are three orientations, 3px, 3py, 3pz. Yes. So a particular 3p orbital can accommodate how many electrons? 2 electrons. It can accommodate 2 electrons. So for n is equal to 3 and L is equal to 1, the subshell is 3p, and a particular 3p orbital will have how many electrons? It will have only 3 electrons. It will have only 3 electrons. Sorry, 2 electrons. It will have only 2 electrons. Which of the following pairs of d orbitals will have electron density along the axis? We have discussed d orbital has got how many? D orbital has got m is equal to, see, L for d orbital is 2, it is 3, I'm sorry. L is equal to 0, s orbital, L is equal to 1, p orbital, L is equal to 2, d orbital, L is equal to 3, f orbital. So it is 2, then m will be minus 2, minus 1, 0, plus 1, plus 2. So there are 5 orbitals for d subshell. And which are those? dxy, dyz, dzx, it's not 2x, it is zx, dx square, y square, and dz square. So these are the 5 orbitals. If you see dxy, suppose I say this is dxy, the lobes are present like this. The lobes have present, that lobes means what? Electron density. Yes, it is in between the axis. dyz, this is y, this is z. Again, the electron density is present in between the axis. dzx, zx, it is present in between the axis. These lobes represent what? Electron density. dx square, y square, it is present along the axis. Yes, it is present along the axis. dz square, this is dz square, it is also along the axis. Therefore, we say dx square, y square and dz square orbitals, they have electron density along the axis. Along the axis. Whereas dxy, dyz and dzx, they have electron density in between the axis. In between the axis. So our question says, which of the following pairs of d orbitals will have electron density along the axis? So which will have along the axis? dz square and dx square, y square. These will have electron density along the axis. So option C is the correct option. Next question. Two electrons occupying the same orbital are distinguished by. Two electrons occupying the same orbital are distinguished by. How do you distinguish the two electrons which occupy same orbital? This is nothing but which rule? Pauli's exclusion principle. No two electrons will have all 4 quantum numbers same, or I can say the two electrons of the each orbital, they will have different spin quantum number. So I can say for two electrons occupying same orbital, so they are occupying same orbital, where values of principal quantum number, azimuthal quantum number and magnetic quantum number are same. Yes or no? So when the orbital is same, suppose say they are occupying 1s orbital. So principal quantum number for both the electrons will be 1. Azimuthal quantum number for both the electrons will be 0. Magnetic also will be 0. But spin quantum number is different. If one electron is having clockwise spin up, and another electron will have anti-clockwise spin down. So which will be different? Spin quantum number will be different. So how do we say it? For two electrons occupying same orbital, the values of principal, azimuthal and magnetic quantum numbers are same, but spin quantum number is different. One is with positive spin, plus half, and another one is minus half, or spin up and spin down. So spin quantum number differs. Which is the correct order of increasing energy of the listed orbitals in the atom of titanium? Titanium atomic number is given. So titanium atomic number is 22. So let us write the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 10 plus 18, then comes 4s2, 20, then 3d2. Correct? So this is the order, electronic configuration of titanium. So order of increasing energies comes how? So this is having lower energy, then comes this, then comes this, then comes this. So 3s, then we have 3p, then we have 4s, and then we have 3d. So this was being asked. This is the correct option. The correct option is 3s. Where is 3s? 3s, 3p. It is not 3d. It is 4s and 3d. So C is the correct option. C is the correct option. The number of d electrons in Fe plus 2 is not equal to the number of electrons in which of the following? D electrons in Fe, P electrons in Ne, S electrons in Mg, P electrons in chlorine. So let us see. Let us take an example. Okay, let us work on this. So number of d electrons in Fe plus 2. Iron atomic number is 26. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. This is 18, 20 and 6. Correct? This is the electronic configuration. Fe plus 2 means what? Plus 2 means there is loss of 2 electrons. Fe plus 2 is removing 2 electrons, right? Plus 2 stands for loss of 2 electrons. So plus 2 stands for loss of 2 electrons. So how do we write the electronic configuration for Fe plus 2? 1s2, 2s2, 2p6. Electrons have to be removed from the outermost shell, 3p6. Here the outermost shell is 4s. Energy of this orbital is less, but the outermost shell is this, right? So it becomes 3d6. Correct? 3d6. Okay. So what the question is? The question is, what is the question? The number of electrons, the number of d electrons in Fe plus 2 as is not equal to the number of electrons in which of the following. Okay. So here d electrons. So how many d electrons are there? There are 6 d electrons. Another question, d electrons in Fe. How many d electrons are there in Fe? There are 6 electrons again. Correct? Is not equal to the above. So in Fe there are 6 d electrons. Okay. Next is p electrons in neon. So Ne, 1s2, 2s2, 2p6. So neon has 6 p electrons. Okay. Next, s electrons in magnesium. Magnesium atomic number is 12. 1s2, 2s2, 2p6, 3s2. So this is 12. So in S, how many electrons are there in magnesium? There are 6. So S electrons in magnesium. Chlorine, P electrons in chlorine. Atomic number of chlorine is 17. 1s2, 2s2, 2p6, 3s2, 3p5. Correct? How many electrons, P electrons in chlorine? There are 6 plus 5, 11 electrons. So number of d electrons in Fe plus 2 ion are 6. In rest all, Fe also there are 6 d electrons. Neon there are 6 p electrons. Magnesium there are 6 s electrons. But in chlorine there are 11 p electrons. So this is not matching with our answer. So the question is, number of electrons, d electrons in Fe plus 2 ion is not equal to number of electrons in which of the following? It is correct option is p electrons in chlorine. P electrons in chlorine. The angular momentum of the electron in d orbital is equal to. Yes, we have already discussed the formula for angular momentum. Yes, angular momentum is equal to root of L into L plus 1 to H. This is angular momentum formula. For d orbital, L is equal to what? L is equal to 2. Therefore, how do we write angular momentum? Angular momentum is equal to root of 2 into 2 plus 1. 2 plus 1 is 3. 3 2s are 6. So it is, it is 6h. Yes. So it is equal to what? Root of 6h. So the correct option is root of 6h, h cap. Next question. What is the maximum number of orbitals that can be identified with the following quantum numbers? N is equal to 3, L is equal to 1 and M is equal to 0. For this orbitals, what are the maximum number of orbitals for this quantum number? Okay. Now see, N is equal to 3, L is equal to 1 and M is equal to 0. Okay. If N is equal to 3, that means we are talking about third shell. L is equal to 1, it is P. And for L is equal to 1, M value is very how? Minus 1, 0, plus 1. And they are saying M is 0. Yes, that means 0 is for what? It is for PZ. It is for PZ. Therefore, this orbital is 3PZ. So this, for this set, only one orbital has following set of quantum numbers. Only one orbital, that is 3pz, has this following set of quantum numbers. So the correct option is, it is 1. It is 1. Next question. What is the maximum number of electrons can be associated with the following set of quantum numbers? These are most frequently asked questions. Maximum number of electrons for the following set of quantum numbers. So they have given the quantum numbers as n is equal to 3, L is equal to 1 and M is equal to minus 1. N is equal to 3, it is 3. L is equal to 1, that means it is P. Okay. The orbital associated with n is equal to 3 and L is equal to 1 is 3p. There is only one value of azimuthal quantum number, magnetic quantum number, that is minus 1. So I can say only one orbital of 3p is used. Only one orbital of 3p with M is equal to minus 1 is there of the 3p subshell. So only one orbital means each orbital will have maximum how many electrons? It will have 2 electrons. If they would have mentioned minus 1, 0, plus 1, then we would have written 2 electrons here, 2 electrons here and 2 electrons here, altogether 6. But here they have mentioned only minus 1. So therefore only one orbital, and we know that each orbital can accommodate 2 electrons. Therefore, how many electrons? It is 2 electrons. It is 2 electrons. The outermost electronic configuration of GD, gadolinium element, is atomic number is 64. Yes, we write the configuration for gadolinium as 64 means a xenon, 56, 4f7, 5d1 and 6s2. This is an F block element which comes under lanthanoids and actinoids. So the correct option is option B. It is option B. Maximum number of electrons in the subshell with L is equal to 3 and N is equal to 4. So N is equal to 4, L is equal to 3. So 3 means what? It is D. Sorry, it is F. For 2, L is equal to 2, it is D. So 4F, it represents what? 4F subshell. So they have said subshell. 4F subshell, you have the formula. Total number of electrons in a subshell when you have L value is given by 2 into 2L plus 1 or 4L plus 2. So 2 into 2 into L value is 3 plus 1. 2 3s are 6. 6 plus 1 is 7. 7 2s are 14 electrons. Or directly F, if they say it is understood how many electrons, it is 14. Correct? This is the formula we have discussed when we were discussing magnetic quantum number also. Next question. The correct set of 4 quantum numbers for the valence electron of rubidium, atomic number 37. So when atomic number is 37, rubidium atomic number is 37. I'll just show you the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So 10 plus 10, 20, 30. Then 4p6, 5s, 1. So total 37. So outermost, what the question is, correct set of quantum numbers for valence electron. So this is the valence electron. Yes. So valence shell represents. So this is first shell, second shell, third shell. This is last shell. So outermost shell represents valence electrons. So valence shell has got which subshell? 5s1. For 5s, what is the value of n? N is 5. What is the value of L? L is, for S subshell L is 0. What is the value of M? M is also 0. What is the value of S? S can be plus half or it can be minus half. We cannot always say it is plus half only or it is minus half only. It may be plus half, it may be minus half. So 5, 0, 0 plus half or minus half. So plus half is given. So option C is the correct option. So we'll stop the questions here. Further, the next set of questions I'll be taking up in the next class. For now, I hope you have understood with these questions. Please practice all the formulae and the concepts regarding this. We'll discuss the next set of questions in the next class. Thank you.